In this presentation, we're going to evaluate convective cells for lightning potential. And right now, our current live time is 14:19 Zulu. Our product time is 13:47. So approximately a half hour prior to live. So what we want to do is we want to keep as close to live time as we can on this. We're going to chase after these cells up to the northwest of Miami. We're on Miami's next rad there, KMX. And these cells are about 30 miles to the west-northwest. First thing we're going to do is state our empirical rules. First rule is we're going to look for echotops reaching the minus 20 altitude, the glaciation level, minus 20 degrees Celsius. And we'll show you in a second where we're going to get that value from. After we establish that first rule, if we've got a cell that's reaching that level, that threshold, then we're going to cut either, using GR2 analysis, we're going to cut either a cross section, 2D, or a volumetric mode, 3D volume section. And we're going to look for convective core. And if the convective core reaches the minus 10 altitude and has 40 dBz's up to that altitude, then we're going to make the statement that that cell is supporting lightning. So whether it's picking up on lightning detection or not, we're going to want to have a lightning watch out for that cell. All right, let's start out here. In our first frame, once again, we're at 1347Z. And our tops are not quite that exciting. They're about 18,000 feet, kind of getting in the ballpark. Remember, we have to get our echo tops past 26,000 feet, and then our convective core's got to reach about 20,000 to 21,000 feet. So right now, that first step is not happening. We'll go ahead and cut a cross section through there, though. Take a look and see what it looks like in that respect. Tell you what, I didn't like that one too well. Let's do it again. Let's go west to east. No, for no particular reason, just a little better fit there maybe. Nope, it wasn't actually. But we can adjust for that using the position slider. And it looks like we're kind of maxing out our cell right there. And you can actually swing it to pivot it in 2D cross section. So our minus 10's up here just a hair over 20,000 feet. And we're not even close to. We do have convective cores in there, but they're strong. They've got over 40 dBz. They're just not high enough. We need to get them up to 20,000 feet for lightning. So that first volume scan, no luck there. We'll step it ahead one or two. And there's one. And it looks like we got a little bit higher top, still only about 21,000 feet. We'll shoot a cross section through there just for the heck of it. 47 after. Max it out, slide our slider bar around. So we are reaching now 20,000 feet, but that's pretty close right there. We got about 36 dBz, so not quite our 40 dBz core. A little bitty hail spike right there, it looks like almost. So we're not quite there on the second empirical rule yet. Let's go ahead and step it forward. We've got the Blitzer tongue lightning place file running, so as soon as we do get some lightning, it should show up on that place file. All right, so now we got 28,000. Now we've met the first empirical rule. We needed 26,000 feet, and we've got it now. So I'm holding down control on GR2 analyst and mousing around. You can see our max top there is at 28. So let's cut a cross section through there. Max it out here, slide our slider bar around. There, it looks like that's probably what's pinging our max top right in there. We've got some good returns, but our convective core just isn't reaching minus 20 yet, or minus 10 rather. Convective core, 40 dBz's, reaching minus 10. If we say split the difference, the red lines are minus 20, yellow lines your freezing level. So our minus 10 should be right over the 20,000 foot line there. So not quite there yet, even though we got the echo tops. So this might save a false alarm because we're looking for 26,000 foot tops, and we got basically 29,000 foot tops, but the convective core just isn't stout enough, hasn't got the height to it. So 21 is kind of dropping there. And still not quite there. We'll just do a cross section for the practice there. And it's got a good convective core in there. Pretty vigorous. Going to be a good rain shower, but no lightning. Okay, next frame, we got 23,000 feet. Cross section through there. good convective core, but no luck reaching the -10. And the cell just kind of losing all of its updraft strength. So the lesson here is that if we only live and die by echotops, you might have had a false alarm on this cell. If we'd have issued back here where we hit the 27,000 feet, 29,000 feet, if we would have issued a lightning watch at that point, it would have been a false alarm because you need to take it to the second step there. See our convective core, and it just barely didn't make it. It was close though. I would have wanted to have a lightning watch. If I saw this, I probably would have wanted to see a lightning watch out for this cell. But it did not drop any strikes. So it was close. So in review, our echotops reaching -20 altitude, then cut a cross section or volume section, see if we got a convective core, and if that convective core has at least 40 dBz's in it, does that reach -10 altitude? And you can use that to manually or subjectively verify lightning watch.